Hmm. Today we'll begin with the version control system. First, let us learn what is a version control system. Why do we need a version control system from the Devops perspective? So what are the different types of version control systems, and then the architecture of Git, and then we'll proceed from here. So let's begin. So what is a version control system? Some of you might be using it, some of you might be new to it. I'll be going from the beginning. So let me talk about first what is a version control system. Version control system is a system which can help you manage files for your project. What is meant by managing the files? Let's take a simple example. The first use case. Let's assume a team of people working on a bunch of files. Okay, there's a team of people who are working on a bunch of files. And I'm talking about a scenario where they are not using any version control systems. Okay, so a team of people are working on it. They have placed all the files in this shared folder or shared drive. They are not using any version control systems. Let's say there is a developer A. Okay, or else a DevOps engineer. Okay, let's talk about a user who is working on this file one. He bought this file. He brought this file to his local computer. And there is another person, okay, B, who want to work on the same file. So B also got this file to his local computer, the same file. Okay, so both of them downloaded this file to their local computer, made changes, and they want to put this back. They want to put these changes back. Okay, they have placed these changes back to the shared folder. A has kept this file back on day 1. B has kept the file back on day 2. So finally, after 2 days, this shared folder will have which person changes? After day 2, this folder will have which person changes? Will the person A changes will be there, or will the person B changes? Whose changes will be there after day 2? Obviously, only person B changes will be there after day 2, because what is happening here? B changes are overwriting the changes of A. B is overwriting the changes of A. So B doesn't know that he is doing it. Similarly, A doesn't know that his changes are overwritten. So this keep on continuing if you don't use any version control system, right? If multiple people are working on it and if they want to work on the same file, they keep modifying the same file and the changes gets overwritten this way. If this keep on continuing, at some point of time, sorry, at some point of the project gets corrupted or messed up, right? So how to avoid this? So how to avoid this issue? That's where version control system comes in. Version control system is the one which can help you avoid overwriting or messed up when multiple people working on it. It will help you. It will allow multiple people working on the same file at the same time. How it will allow? We are going to see different use cases, different scenarios with a hands-on. Okay, I'm first explaining the scenarios, then we are going to execute all of these with a hands-on. So that's the first thing. And the second thing is, let's suppose, okay, the code changes are done, the application is working fine till 6 o'clock. Suddenly at 6:10, application crashed and the business is going down. You want to immediately revert the changes. So if that is the case, you have to look at, like, you need a detailed history on which person made changes on which file and where did he made the changes on line 8 at 6 a.m. at 6 a.m. on 7th April, something like this. A detailed history is needed so that if I see this, okay, I understand, okay, this change led to the crash, immediately revert this change. So a detailed history is needed, right? Which is not possible manually. You can't sit and manage this log, manage this history. You need a system which can help you with this kind of detailed logging. So that's where again version control system comes in. Right, not only this, let's suppose another use case. Let's say you are working on some changes, you have a version 1 of this file. Client came with some modifications and suggested to make a version 2. You have modified or edited version 1, means there is no more version 1, you modified it and made version 2. But after 6 months, client again want to go back to previous version because version 2 is not working for them, is not bringing good results, version 2. So they want to go back. You have to do all the rework again. Instead, you could have maintained backups, maintained versions, right? All of them are possible through version controlling. First thing, it allows multiple people working on the same files, okay, parallelly. It will allow it will allow multiple people working on the same file at the same time. It will help you with a detailed logging. It will help you to maintain the versions or backups, right? So these are all some of the advantages of a version control system, right? So without which the projects may not be managed efficiently and effectively. Now, a question comes in, what can be version controlled? Any static files can be version controlled. Any program files, irrespective of whether it is Java or .NET or Perl, Python, PHP, not only that, any config files, any shell scripts, anything, any simple text file can be version controlled. So when when we talk about what it can version controlled, this answer is very clear, I believe. Who should use it? Yes, developers will use it. That's a mandatory for them. Even testers will use it. They do have automation test scripts and all. Even ops teams will use it. They have some config files, scripts, and so on. Even the same is the case with the DevOps team. They have Docker files for containerization. They have config files, Terraform config files, Kubernetes manifest files. Any files can be version controlled. So who should learn it? I would say everyone and anyone in IT should learn it. It's a mandatory for everyone. Am I clear? This is the one perspective of learning version control system. What is the other perspective? Is that just to manage our files, DevOps engineers will use it, or is there any other perspective? Definitely, there is another way. Whenever developers write the code and place it in their version control system. Yesterday and day before, we were talking about CI/CD, right? Whenever any person make a changes, right, in their code, that should immediately go to the production. Means we need a system which can identify, okay, some changes there on the version control system, let's pull it. So how do we identify it? So that's where comes this version control system integration into the CI/CD part. So that's another perspective DevOps engineer should learn. Of course, everyone should learn. Developers are making changes. They should know how their code would be triggering the pipeline, right? So that those are the two aspects of learning version control system. First, we'll get started with managing the files, like how can multiple people work on it, how does it provide logging, versioning, all of that. From the basics till advanced concept, we'll master everything on Git. Then we'll go for the second perspective of integrating it into the CI/CD pipeline. Hope this much is clear for everyone. This is the same strategy we apply for any tool coming up in the course, like it could be Git or Docker or Jenkins, whatever it is. First, we learn from the basics till advanced. We do all the hands-on, all the scenarios, all the use cases, then implement into the pipeline. Again, in the pipeline, we have different use cases and scenarios. So good to go. I just explained what is a version control system, who should use it, why we should use it. Good to go. Appreciate your quick responses and interactiveness. So we understood what is a version control system. Now let's talk about types of version control systems. There are different types of version control systems, like centralized version control systems and distributed version control systems. What is a centralized version control systems and how are they categorized? They were categorized based on their architecture. If you look into centralized version control systems, like you can see a central server or a remote server where all the project work, all the work would happen, and there is a individual developer's workstation. This is the workstation of individual developer or collaborator. You may call, see, it could be a DevOps project or development project or testing project. So you consider a DevOps engineer or a user, right? So this is the workstation of each individual user. If you consider a development team, each developer, or a DevOps team, each DevOps engineer. So each one will have a copy of the remote repository or the central server into their local, and that's where they make the changes. Once they make their changes, they'll push their changes to the remote. That's how it works. They will pull the changes to their local, make the changes and put it back. Right? This is the simple architecture of centralized version control system. The challenge is networks or network connectivity. Always network should be intact. If there is any broken networks, you may not be able to work with a central server. Entire work would be halted, right? So always network connections should be there. That's the first thing. Second thing is, let's say for some reason the central server got crashed. Something happened to it, it got crashed, lost, all the changes lost. Yes, entire changes would be lost because it works like a single source of truth. These are the certain challenges you have with the centralized version control system. And what are all the version control systems we have? We have so many. And out of it, TFS, Perforce falls under the centralized version control. Also, SVN falls under the centralized version control systems. Right? There were certain drawbacks as I listed. To overcome this, we have another type of architecture called distributed version control systems. This is the architecture of distributed version control system. Git is a distributed version control system. Mercurial, Fossils comes under distributed version control systems. And all the modern DevOps projects uses Git for the reasons of its availability and flexibility. Let's learn like what is a distributed so that you will understand how it overcomes the challenges posed by centralized version control system. So if you see there is a central server or remote server, and this is the workstation of each collaborator, each user. Okay, this is the workstation. This is my local computer. So now this is called remote repository or the central repository, whatever you may call it. This is every user will have a local repository. Okay, a copy of the central repository. And each time will not work directly again on this local. There is something else, some other folder called working directory. You may call it as a folder or a directory, whatever it is. Like, so you'll have a separate folder where you do the actual work and then push your changes to local. From local, you push your changes to remote. So the first challenge, you don't need network connectivity at least to continue your work. You need network connectivity only to push to remote, right? You need network connectivity only when you push or when you get a copy. You get a copy once and later on you keep updating, right? You don't get a copy every day. So pull and push are less frequently used commands. You do entire work on your local, then you push or pull. Correct? So they are less frequently used. So you don't need network connectivity. You need network connectivity only once entire work is done. Means entire work is not halted. You can still continue working on your local repository. Is this much clear, everyone? So, yeah. Mm. Entire work is not halted. You can still also another advantage is because you majority of the time you're working on local, it's just accessing your hard disk. Obviously, it's faster, right? Distributed version control systems are also faster. Okay, and let's say the central server got crashed, something went wrong. Chances of recovery are more because each developer has got a copy of it, right? This one, they have a local copy, they can recover from here. Everyone is having a copy of the remote. So chances of recovery are more. Good chances of recovery. So these are the advantages of distributed version control systems. Git falls under this category. And because of these advantages, majority of the DevOps projects uses Git. Git is very widely used. Am I clear with this architecture? How it will help override the changes, all of those with the hands-on we have to see. Is this architecture, general architecture of distributed version control systems clear for everyone? Right. Considering this as a confirmation, let me move. So this is the comparison of a Git with other version control systems like SVN, TFS, fossils. You can see the blue graph is Git. There is no clear winner in this category. I mean, Git is the clear winner in the category. There is no good competitor in this category for Git. Git is too widely used and we are mastering Git here. If you learn Git, you can switch to any other tool very easily. Right, this is a graph from 2020. You can also get the latest graph. Now, let us get into the architecture of Git in particular. We discussed about the architecture of distributed version control system in general, right? That's the architecture of distributed version control system in general. Let's talk about the architecture of Git in particular. So if you see, this is your local computer, which we are talking about, and this is the remote one. Okay, now, like we discussed, we make changes and push to local. It's not directly we are making changes to local. I mentioned this before also. There is another directory called working directory where you make changes actually. And then again, it's not from working directory you push to local. No, that's not possible, right? You cannot push directly to local. Rather, you will first push to staging. From staging, you have to push to local. But what is the staging area? Staging area is also called as index area, right? So it's a virtual layer in between your working directory and local repository. It's also called as index area. But does it has got any importance? Yes, of course. It works like a preview or else a pre-check to check your changes. It works like a preview or a pre-check before your changes goes to local. Is that making sense? So from working directory, you move your changes to staging area. From staging area, you move your changes to local repository. So before you move your changes to local, it works like a preview or else pre-check before they go to local. Means let me give a simple example. Anyway, we are going to do all these scenarios with a hands-on in some time, but just let me tell you, let's say you have 10 files you're working on. You want only 5 files to go to local repository. You can add only 5 files to the staging area, right? So that's how it will give you a better control on what changes are going to your local repository. Okay. So from working directory, your changes goes to staging area, from staging area to local repository. From local repository only, it can go to remote. What are the commands used and all we will learn. Means it's called Git tree. It's like a 3 steps before your changes reaches remote. You cannot just directly push from here to remote or from here to local. No, you have to follow the hierarchy. That's called Git tree. And a most important thing, unless until you push your changes to remote, those changes are confined only for yourself. No one else can see those changes until you push them to remote repository. Remote repository is the one which is shared across everyone in the team. This is the Git architecture. If this much is clear, I would like to give very interesting points here. First thing, we are talking about working directory, local repository, right? Imagine they are just folders, some folders in your system. Working directory, local repository is one and the same. Yes, that is the same folder. Then why are you calling as a working directory and local repository? Isn't it? It's the same folder. Then how come you call working directory and local repository? Physically, they are same. But logically, they are different. What is meant by that again? Logically, how they are different? Let's see. Let's suppose this is your working directory, a folder in your system. This is your working directory. If you just created a file here or brought some file and placed a file here for version controlling, it is said to be in the working directory. After creating or copying from some other location, if you run the command git add, it is said to be in the staging area. Okay, after adding it, if you commit those changes with this command, then it is said to be in the local repository. It is in the same physical directory. That's how logically it is different. Is that making sense and is this much clear everyone now? Right? That's how means it's the same folder. So working directory, local repository one and the same, and staging area is a virtual layer. So you don't see separate folders, but you will see the you will see the how logically it's moving across the working directory, staging area, and local repository. Any questions on this part from anyone? You can feel free to raise the hand if you have to ask any questions. Okay, so this is one thing, right? The other thing is, the another interesting part is how do you create a local repository, isn't it? How to create a local repository. There are different scenarios or use cases. How do you create it? First one is you can create a local repository. Create an empty local repository manually. Okay, develop the changes, develop your config files, and then move to remote. Okay, let's suppose it's a new project. There's nothing on remote. It's a fresh project starting from scratch as a DevOps engineer. You don't have anything on remote. So you create an empty manual repository and work on it and then push to remote. That is one use case. Another use case could be already it's a running project. It's a 6-year-old project. So there is something on remote. So you join the team today. So copy from remote and create a local repository. That is another way you can create a local repository. We will cover both the use cases. Today, we'll first get started with this use case. The second use case will be covered in the due course, like maybe tomorrow or day after. But we'll get started. Assuming it's a new project, we are all new. This is a new project. Let's create an empty manual repository, develop the files, and then move to remote. Is this much good? Should I repeat anything? Anyone lost anywhere? Thank you, Anbalagan, for confirming. Brief explanation for Samatha. Brief explanation on the architecture. So Git has got a 3-tier architecture. From working directory, it will move to staging area. From staging area to local repos, and then we have to move to remote repos. It's like a 3 steps before changes goes to remote, right? And here the interesting points are local directory, local repository, and the working directory are the same folder. Physically, it's one and the same folder, but logically, it's different. How logically it's different? Whenever you create any file here, right, that is set to be in a working directory. If you just created a file, it is set to be in the working directory. Once you run the command git add, it will go to the staging area. And once you do the commit, it will go to local repo. That's how your changes navigate from each level or each layer. And this is called git tree. Right, that's what we have discussed. And staging area is a virtual layer or a virtual area. It works like an index area or a preview or a pre-check before your changes goes to local. Right, and the other one is remote repository. Remote repository is you push to remote. Right, you can push your changes to remote repository. Once you push your changes to remote, then only others can visualize those changes. Until unless you push the changes, if they are only in your local repository, no one else can see those changes. And these are the two ways you can create a local repository. Let's suppose it's a new project. It's a starting from the scratch. So you can create the repository manually, make the changes there. Okay, and then that's how you can proceed. Create an empty one and all. Let's say it's already you joined a project, a running project. Already some changes were there. So you can copy from remote and create a local repository. Those are the two scenarios I mentioned, which we'll be covering in this course, like how do you create a local repository. So that is the architecture of Git. If this is clear theoretically, we will proceed and get to the hands-on, and we are going to see all of this in the lab, like what is a working directory, what is a local repository. We are going to see all of that. Good to proceed. Right. After this recap, let's get started. So Git works on multiple operating systems. Okay, Git works on Windows, Linux, Mac. Okay, it supports multiple operating systems. So you can directly use Git in your own laptop. Okay, you don't need any AWS or anything as of now. We will need AWS in the coming up sessions, but for now, yes, anyone, like everyone can use your own laptop, whatever be the operating system. Okay, so now go to your laptop and how do you install it? Right, let's see. All these steps will be available. Okay, first let me show you where are these steps available. So go to live classes. By now you all got your LMS, so you may just go from here. You can go from here to the My Learnings and also go there, or else go to live classes. Okay, go to the lab assignments. Also open the lab notes. First, go to lab assignments, Git, or else you can go to your LMS right away. It will take you to this. So here all the steps. How do you install on Git? How do you install on Mac? How do you install it on Windows? Sorry, on a Linux, easy to instance. And how do you configure? Everything is there here with the commands and explanation. Okay, this is one thing you have. If you go to the lab notes and if you go to the module 1, which is Git, here, the presentation which I'm showing, the architectural diagram, everything is available here, right? This is the presentation available for you to refer. And the other thing is installation steps were also there. Particularly installation on Windows is there because it just launches a wizard and you need to navigate through. All those steps were available here. Okay. So those are the references you can go to. And today's class, whatever I cover, will be available here. Also, here you have two ways you can refer. Whichever is comfortable for you, you can. For the commands and all, for Git better, you use lab assignments. Okay, when we write files for Kubernetes and all, then you go to this notes. So this is all the steps available for installation, everything. I think installation is also available here. Install Git on Windows and then okay, installing it on different operating systems is also available here. So you have lot of material to refer to. Now let us install Git. This is my way of doing it. Go to Google. This is always the best part. You always go to official documentation. If it is Linux, this command will do apt-get install Git or yum install Git depending on the distribution of the Linux you are using. If it is Mac, also single line, brew install Git will do. But if it is Windows, you all know you have to download this executable. Where is it? So download the executable and run the executable. By now, I think you all know how to do that. Okay, you know how to run a wizard. If you still need a help, screenshots are also available here with the steps. See here. I have placed screenshots. It's about just clicking next button, but still all the screenshots were available so that you wouldn't struggle to do the hands-on or the setup. Okay, so install it. Once it is installed, mine is Mac, so I'll be launching my terminal. If it is a Windows, you can launch, go to start menu and launch git bash. It is there here with the steps. Once it is all installed, if it is Windows, go to your start menu and search for git bash. You will open a git bash terminal where you can run git commands. If it is a Mac, terminal should do. So git is installed. How do you know it? Run the command git version. So git is installed. Perfect. Git is installed on my system. I can use git. But where is the folder or the project work you want to version control? Isn't it? You don't want to version control your entire system, entire laptop, right? So go to the location where you want to version control. On my desktop, I just want to version control some project. You may create a new folder and do it. See, one more thing. You may use CLI to create the folders and files. We will learn that in the next part. So until then, if anyone new to it, you can do it from the GUI. Give me a second. GUI in the sense like go to that location. How do you create files and folders? Just right click, create a folder. That's how you can do it. Okay, create a folder like this and do this. Or else if you are comfortable with the CLI, you can also create from the CLI. How do you create a folder? Simple command is mkdir, make dir. That's a Linux command. Like I told you, we will cover Linux separately after this git. But yeah, I'm using simple command. I have also explained it. If you are not comfortable, use the GUI to create a folder. I'm creating a folder called git demo. So if I do ls, it should list all the files and folders here. So I should see a folder called git demo. This is it. Okay, so this one. Right, this is the one. So now, okay, fine, I have created a folder. Now I want to version control any files and folders kept in this folder because this is going to be my project. So cd change directory means I'm going into this git demo. There's nothing in here. Okay, fine, it's empty, but I'm going to create a config files here for my project. Okay. Now how do you tell Git to version control this particular folder? I want to tell Git to version control any files kept in this particular Git demo because that's going to be my project folder. Or else another way is I want to create this as a local repository, empty local repository. How do you do that? Run the command git init. It will show you all the verbose and it will tell you initialize git repository. Means git repository started. This is your git repository. If you see just list, it won't show anything. It will be a hidden file created, hidden folder created called .git. Here you can see .git created. ls minus a will show the hidden folders. So .git. So what did I do? Listen carefully here. These basics are very important and you should be strong with these basics. So there is a folder. I just created a folder called git demo. If you want to make any particular folder as a version, if you want any folder to be version controlled by Git, that should be a version local repository. How do you make a local repository? Git in it. So that now onwards, if you place any content here, it will be version controlled by Git. So I just created a local repository. See here, you can also see the hidden file. Do you see that? Right? You may see it from the GUI or you may use it from CLI. It's up to you. Are we good? This is what I'm talking about, creating a local repository from the scratch, an empty local repository. Thank you all for thumbs up. I'm proceeding now. Let me create a simple file here to version control. So you may create a file of your choice. As of now, the file content is not our choice, is not our interest. We are focusing on learning it. It could be a Java file, it could be a Python file, it could be a simple script file, whatever it is. So I would like to create a simple text file. I can use the command touch. Touch will create a file. I'm creating a simple text file because like I told you, my interest is not to create any config file as of now. My interest is to just version control any file. So I'm creating text file. It's up to you. You can create any file of your choice. Touch will create a file, right? Touch is again a Linux command. If you're not comfortable, right click and create a file, right? I just created a file. So, okay, fine. Do you remember the architecture we discussed? Always this architectural diagram should be in your mind. Which architectural diagram? Hmm. Okay, let me launch it here. Mhm. Okay, always this architectural diagram should be in your mind. So I just created a file means where is this file? Is it in the working directory or staging area, local repository? We just discussed theoretically. So now tell me, I just created a file. Where is this file? I'm expecting responses from each and every one of you. It is in the working directory, right? If you want to confirm, you can run the command git status. Git status will tell you untracked file. Means git know there is a file, but git is not able to track it. Git could not track it. Git is not tracking it. It know there is a file, but it's not tracking it. So where is the file said to be? It is clearly telling you Untracked file present, add it to the staging area. Only once you add it to the staging area, it can be tracked, is what it is telling. Correct? So now what you have to do to move it to the staging area? Git add that file, right? So now again do the status. It clearly tells you, it's not telling you untracked. Do you see the difference? It is tracked now, right? It is not telling you it is untracked. It is just telling you changes to be committed. Means where are those changes? Where are those changes now? Changes are in the staging area. Changes to be committed, not yet committed. See this diagram. To be committed means it is in the staging area, right? That's how you confirm. Now you run the commit, you run the command commit, git commit. -m is for message. Message is mandatory. Why it will mandatory? I'll tell you. Let's say first file. That's all. Right now, if you again run git status, it will tell you working tree is clean. Working tree is clean means like whatever changes there, but all there in the local repository. If you see physically, it's the same folder git demo. Git demo is your working directory. Git demo is your staging area. Am I making sense? Git demo is the working directory. It is also your local repository and staging area. Got it now what we discussed some time back? Understood? Let me repeat the same with another file so that it should be clear for all of you. I am just creating one more file called file2. Okay, now tell me where is this file2? I want answers from each and every one. Exactly. I see responses from everyone. Thank you all for responding. Yes, it is in the working directory. How do you know? Git status. See, untracked file 2. It's again saying it's untracked file 2. Another thing is you can also do git ls files. Git ls files will list the files in the staging area and working directory. See, it is listing only file 1. Right? So this is one way to check this. And another way is right, as if this is another way is git status. Now, okay, fine, this file is well. What should we do? Git add file 2. Done. Now, if you see status, changes to be committed means where is this file? In the staging area, exactly. So what I'll do, git commit -m, and then I'll say second file, right? So you can see that as ls, the list of the files, git ls files, it should be listed under this as well. That's how you navigate from working directory to staging area, from staging area to local repository. This kind of clarity is very important because we see people working in the project without having this kind of clarity, right? With which you cannot answer in the interviews or else you may not be stuck up in your projects. But if you have this kind of clarity, you can troubleshoot any sort of scenarios and work on the projects comfortably. Got it clear, everyone, with respect to the staging area, working directory? Is this much good? Okay. So if this much is good for you all, let's proceed to another interesting part. See, till now we made some commits, right? And we discussed like it should be showing us the changes, whatever made by us, right? So till now, whatever changes you make, you can see with a command called git log. Git log will show you the complete list of commits we have done. We have done 2 commits and every commit will be generated with a hash code ID, alphanumeric hash code like this. And you can see the author name, the timestamp when it made changes and the commit message. Right? That's why commit message is very important, because at a later point of time, maybe after 10 days or so, if you want to see and understand what changes were those about, this commit message will give you a hint on what changes those were all about. Right? And you may be wondering how come you are seeing here the name and all, right? For the first time of running commit command, you should run a command called git config global username and email. For me, it doesn't ask me because I am already using git here. If you are using git for the first time, you should run these commands as well. See, configure your git with some username, with some email ID, so that your commits will be registered with this email ID and the username. That's only one time task. If you do one time on your system, that's all. Got it? And every command, whichever I have used here, is given with explanation. So that's how you'll have the author timestamp. That's what we are talking about, right? We need a detailed timestamp of when these changes were made. So these are the ones. Let's suppose you just want to see a brief log, not the entire log. You can use one line flag to git log command. One line means first 6 characters will be shown. First 6 characters are enough to refer to any commit. You don't need the entire commit hash. So it will just show you brief commit history. Got it? And okay, let's suppose if you are seeing this commit history, this message will tell you, okay, this is some changes relevant to first file, something relevant to second file and all. You can give a good commit message. Message should be good so that you will understand what this commit is all about. And if you want to see the changes happened in a particular commit, git show that first 7 characters. See, it will show you what changes went in. New file is created, that's all. We did not add any lines into that, right? So we just created a file. You might have added some content also. That's how you can see the changes went in there. Okay. And what else? Okay, till now we created the files, right? If you want to modify, how do you do that? You may just go to your Windows Explorer, open the file like this, right? So you can open it like this and type in something. If it is Windows or any operating system, you may use a notepad or notepad plus plus or a word pad, anything you can use, right? There are good editors, professional editors we can use as well to modify our files, to better visualize your Git repositories. One such editor is called VS Code editor. It is just an editor, okay? It's not any technology. Anyone can use it who want to modify the files. Like your notepad, notepad plus plus. This is just an editor. So go here and download the editor. Again, it is available for all operating systems. It's available for Mac, Windows, and so on. Just download it and launch it. That's all. Open it. That's all. You don't need to do anything. Other platforms. Okay, see here, if it is Windows, download the executable, download it. Once it is downloaded, double click to launch it. That's all. Similarly, you have got it for Linux, you have got it for Mac, right? Even those steps of using it will be available in the steps here. Okay, so I would like to launch my repository in the VS Code. Once you install it, you can launch your VS Code editor. It just looks like this. How do you see your project here? Go to File, open the folder, open the Git demo is our folder, right? Open this. See, you can see, I think I opened the wrong one. Just a second. Open the folder on the desktop. Okay, see, I can see, of course, there are empty files, but I can see that. And for commands, I'm running a terminal, right? I'm running on a terminal like this. You can launch your terminal here itself in the same window so that it works like a single window to see everything. Just go here, terminal, new terminal. See here itself, you will see your terminal. If you want, you can go to this plus, drop down, bash terminal. You will see your git bash terminal here. Right? As simple as that. Okay. Are we good? Till now, we just created a files. There are many advantages of using this VS Code editor, I'll tell you. But before that, good to proceed. Till now, we just created new files. Shall we go and modify the files? Isn't it? It's not always you create new files. You may have to modify the files. So shall we proceed? Or any questions from anyone here? All right. So thanks for confirmation. Now let's proceed. Let's say I want to modify this file. Means I want to add some content, make some modifications. So here is the editor, a better editor. You may write anything you want. I'm just writing some dummy line as I made some modification. Do you see here? It shows like a M modified. Also do git status. What it will tell you? See, changes not staged. What does it mean? Either it is a new file or a modification, Git works in the same way. Means firstly your changes will be in the working directory. Then your changes, it could be a modification. It could be creating a file. Git works with respect to changes. Change could be anything. It could be creating a new file. It could be modifying a file. It could be it could be deleting a file as well. Git works with respect to changes. So now the change is in the working directory. Changes not staged means unstaged changes. Where are those unstaged changes? Anyone? Where are those unstaged changes? Unstaged. See the architectural diagram. Refer to the architectural diagram. What is meant by unstaged changes? Unstaged, exactly. It is in the working directory. Unstaged changes means your changes are in the working directory. Right? So what you have to do, again you have to do add and commit. Let me ask you one more question. Earlier we have seen untracked. Where are untracked changes? Also in the working directory. So what is the difference between unstaged and untracked? Do you see the difference in the message? Now it was not showing untracked. It was saying unstaged. What is the difference between them? Can anyone? Exactly, Prabhu. Correct. If it is a new file for the first time, it will show like untracked. Unstaged means file is already there in the staging area, already changes are committed, new modifications will be shown as untracked. Okay, you need, sorry, unstaged. So you need to get this clarity. Both are in working directory only. If it is a first time, it's a new file, it will be shown like untracked. Already file is there, but it is some modification, it will be like unstaged. So that could be again an important interview question. Differences between unstaged and untracked changes. Right? So what do? You have to do git add and then git commit. Here also same. You can do git add, git commit. But there is an advantage, another additional thing you can do for unstaged changes. You can do the command separately, or else because it's not a new file, you can also do -am. -a means add and commit. Instead of just using simply a and add and commit separately, you can do with a single command for unstaged changes. But you cannot do this for untracked changes. Understood? So now I can do git add and I can do git commit, or else because it is unstaged, I can do with a single command. That's what it was telling you also, clue, right? Git commit minus a means add and commit. File modifications is the message I am giving. The messages are user defined. You can give message of your choice. Understood? Yes or a no? Thank you. Thanks everyone for confirmation. So let me run this command. So perfect. Here, the advantage of using one more advantage of using VS Code editor is on the left hand side now M is gone because all the changes were committed. You can see git status. Okay, git status will show you it's a clean, right? If you want, let us repeat it. Let's say for this second file, I'm adding a line like hello. Now you can see here M, instead of checking on the commands on the Explorer itself, you can see. You can do git status. It tells you one stage what you have to do, add and commit. Again, you don't need to give the file name, Rajendra. Whatever in the staging area will be committed with this command. No file name needed. Second file modifications. Right, gone now. Status, it's clean. Whenever you are running, history command will list you all the commands. Let me take you through these commands. See here, git commit minus am. You don't need to provide file name for this. Whatever changes in the staging area, it could be 2 files in the staging area, 3 files, everything will be committed. Okay, but let's suppose in the staging area, there were 3 files. But if you want to commit only 1 file, then you can pass the file name here. Otherwise, file name is not needed if you want to commit everything. Generally, we'll commit everything. But if you want only specific file to be committed, you can give the file name. Understood, Rajendra? And everyone? There is nothing to commit. And whenever you are doing this, because there were no changes, like no modifications, it was not allowing with the A. It just works with minus M. Right? But generally, we will commit whatever in the staging area rather than committing a specific file. Right? And each time we are running this git add git add file name, right? File 1, git add. If I have another file, I will do git add file 2 and so on. But if you want to commit if you want to add multiple files or every file, add a dot. Dot means it will add all the files in the working directory. Those are the simple commands to recollect. So what did we do today? Today, just I would like to recap before I go for the next part. Today we did Git architecture. Of course, we discussed what are version control systems, types of version control systems, architecture of centralized version control system, distributed version control system, architecture of Git. Okay, and then we discussed installation or setup of Git. And then creating an empty local repository with Git. Empty local repository with the Git init, and then git add. These are the commands we have learned. We understood, we got a clarity between working directory, staging area, and local repository. Git commit. We have seen git log. We have seen git log, one line, a brief log. And then we have seen git show, the commit ID, right? And then we have also seen git commit minus am some message. At this point, we also just discussed, okay, we just discussed about git commit particular file and the commit message, right? And also we discussed adding multiple files. This is what we have seen today. It's not git history, it's just simply history, a Linux command. And by the way, we learned one more command, git ls files, which will list the files in the staging area and local repository. Right? Okay, and history is a Linux command. These are the Linux commands we did discuss today. Creating a directory, navigating to a particular folder, ls, ls-a to see hidden files. We will learn these Linux commands again separately as well. This is not needed today. You can just use your UI and do everything. This is an additional part today which we covered. Are we good? So we have many more use cases and scenarios which we'll be progressing with. But if this much is clear, I would like to proceed. Can go ahead. Can I go on? And one more thing, the architectural diagram is very, very important. Always the architectural diagram should be in your mind when you are doing the hands-on. You should relate to the architectural diagram. When it says changes to be committed, you should refer to the architectural diagram to think where were the changes actually. Right? So that's how you should do the learning. The architectural diagrams, the theory, everything was there. The recording will be uploaded into your LMS. Go through the recording and do the hands-on by following the lab assignment. Also, the lab quiz, you should complete the day one's quiz. Okay? All right. So now let us pick up another interesting scenario. Okay, I'm just going to this file one, making one more change, like another modification. So isn't it in the project, we'll keep on modifying our files. So there is some change. Obviously, when you see status, you will see changes, not staged, means unstaged changes. So if you want to see unstaged changes of any file, you can use git diff file name. That will show you unstaged changes of the file. See here, it was showing something like hello, that was unstaged. Okay. Let me do one thing. I would like to stage it. How to stage this file? What should I do to stage this file? Exactly. Thank you. Thank you all for confirming. Git add file one. Okay. Staged. Does it has got any unstaged changes? Git add file one. Now, does it have any unstaged changes? See, no unstaged changes because I just now staged it by running git add. So output of git diff command is null, no output because no unstaged changes. Okay, let me add again. I'm just writing a dummy content. It's up to you. What do you add here? Now does it have any unstaged changes or not? Obviously, see it was showing this as unstaged, right? The third line. So let me add again. I'm just adding it again. So this is not having any unstaged changes now, right? But it has got staged changes. Has it got staged changes or not? Of course it has got. To see the staged changes, git diff staged. It will show you stage. The same third line is staged now, right? So let me make another modification. I'm just adding it. Is it having unstaged change or not? Definitely, the last line take care is an unstaged change. It has also got staged changes because some changes are staged, some changes are unstaged. See, these are all staged. This is unstaged, right? So the same file, some changes are staged, some changes are not staged because I'm keep on modifying it. After adding a line, I did git add, but and then again added few more lines where I did not add git add. So same file can have both staged and unstaged changes. Is the simple logic clear for everyone or any confusions? Appreciate your quick responses. If it is clear, let me know it is clear or whatever. So the same file is having both staged and unstaged changes. That's a simple logic that could ever happen because we would keep on modifying our files. So some of them could be staged, some of them could be unstaged. At this point, if you see status, changes to be committed means where is this file? Changes to be committed means where is this file? Exactly, it is in the staging area. The same file is shown under changes to be changes not staged means where is it? What is meant by not staged? Where is it? Exactly, working directory. So the same file is shown under staging area and working directory. You don't need to get confused. Why is the same file under staging area, under unstaged, under working directory? It could be the simple logic which we discussed some time back, right? So there is a chance that changes could be, the same file could be under both staging and unstaged, staging and working directory as well. So what you should do, simply commit, add and commit, git commit minus a m changes to be committed. Like let's say diff command discuss or whatever, some dummy message, or else new file modifications, add and commit. So yes, it is gone from staging area and local repository. It is in the local repository now. Am I clear with this part? Understood? So that's a simple logic and the simple commands. Git diff file name will show you unstaged changes of the file. Git diff. Git diff will show you unstaged changes or changes in the working directory of file 1, right? Whereas git diff stage, this will show you staged changes of file 1 or whichever present in the staging area. Understood? So sometimes you may make some modifications and leave it in the staging area, or else sometimes you may make modifications and leave it in the working directory. So at that point of time, you will see the same file under both the staging and unstaged. And this is and that's where you will see. So that could be again another important interview question. Like, can we have the same file under both staged and both unstaged and the working directory? Can we have the same file at the same time, both in the working directory and the staging area? Of course, we can have it, and this could be the simple use case. Got it right, all of you? Any questions from anyone in this part? So till now, what we did, we have created a file, right? We have created a file. We have modified a file. We can also work on deleting a file. Deleting we'll pick up tomorrow, right? So whether it is creation or deletion or a modification, Git works with respect to changes. Means first of all, your changes will be working directory, then we'll move to staging area, and then to local repository. That's called the Git tree. From local repository, it should go to remote. We did not go to remote yet. Okay, we did not go to remote repository. Changes are still only in my local repository. They are confined only for myself. I'll push to remote later because I have to learn many things in local before I push to remote. right? So we are still on local repository. Just remember, we are still on this local repository, the yellow box. Understood? We have to go to remote. We did not go to remote yet. We have to learn many other things before we go to remote. So once you go to your LMS, what you have to do today? Go to your LMS. Okay, go here. My learnings. Okay, go to your program. Go to Git part. Okay, till yesterday it was theory, but today we have started our hands-on. So under Git classes, under Git, you should be going to this one. Okay, here lab exercises, quiz, interview questions relevant to that particular day. So do the hands-on, watch the recording, do the hands-on, take the quiz and the interview questions. Retake the quiz if something goes wrong, if some incorrects are there, retake your quiz and master this before we join tomorrow. Tomorrow we shall get started into many other use cases and advanced concepts of Git. Tomorrow we'll start with many interesting aspects of Git. As it is a day one of our hands-on, this is enough for today. Complete your hands-on and we'll get started from here tomorrow. Any more questions, anything you have, I'm here to discuss. We have 15 more minutes. So any questions you have, anything you want to discuss, you can feel free to go ahead. Anything from anyone? So I see it as no questions. So we'll close here and we'll continue tomorrow. Thanks everyone. Have a good day. Bye everyone. Sure, Rajan, like whoever having any questions during the hands-on, we have a WhatsApp group created, right? Please post the screenshots there so we can help you out. Copy and paste your errors in the WhatsApp group. That will help us get back to you quickly. All right then. Bye everyone.